So now I'll show how to create datasets, which are ensembles of process data that you can pull from one or more experiments, and you can then visualize what's inside a dataset and compare responses of different cells, their STAs, receptive fields, and so on. And then you can as well apply the clustering algorithm on it to get the functional type of the cells. So in order to do that, first of all you have to extract the data and initialize the experiments you want to include, as shown in the previous sections. You might want then to compute the STAs for all of the experiments, and then you can use the function setDataset. So the first parameter would be the name of your dataset, which in my case would be my first dataset, and then experiment would be a cell array of experiment names with the name of the experiment that you want to add. So in my case I want to add these two experiments called test and test2. So I run this, and as you can see the dataset is created. I added a few cells from test and test2. So you do not add all the cells, you automatically exclude the ones for which you have rather a bad grade or a bad STA defactorization. So as you know, you can grade cells in the post-processing of the spike sorting, and you can assign grades to the cells from A to E, usually A being the best and E being the worst. So only the cells with good grades are kept and put in the dataset. Similarly, when you run the STA defactorization function, for some cells you will not find a good defactorization, so those cells are not included also. So now I can use the function load dataset, and I can visualize what's inside my dataset. So the first thing you can see in the workspace, it's a structure called cells table, which is the table which sums up information about all the cells in your dataset. So you have the experiment where they come from, the number of the cells in that experiment, the grade, so A being 5, B being 4, and C being 3, and the polarity of the cell, on versus off. So this is automatically estimated based on the temporal component of the STA. You then have other information such as the special component of the STA, the temporal STA, the receptive fields, and the spike times. So as you can see, there is no PSTH saved, but those can be added if you use the function add dataset PSTH. So these would with this you can choose a stimulus type, for example the Euler or the flashes, and this will compute the PSTHs for all the cells for that particular stimulus and add it to the dataset. So let's try, for example, to add PSTHs for the Euler stimulus. So as you can see, the PSTHs is computed successfully and it has been saved. So if I load again my dataset, now I have a PSTHs object Right now there's only the Euler PSTH available, and if you click on it, you will find the PSTHs, the time being that is being used, and so on. The same way I can then add the checkerboard PSTH. And now I have the two together. So this warning here says that I have a dataset composed of 2 experiments, and in these 2 experiments there's both a checkerboard stimulus, which is good, otherwise I could not have done the PSTHs, but there might be some different configurations in the 2 checkerboards, meaning, for example, they might be playing a different frame rate or different versions of the checkerboard. So in that case, it's just up to you to decide if it makes sense to pull PSTHs that come from stimuli that might not be exactly the same or not. So I'll finish by adding also the flicker, and as you can see now there's something new happening. So in my experiment I played the flicker several times under different conditions. So the code is asking me, so which flicker do you want to use to add the PSTH? So the one from section 3, the one from section 5 that at this particular condition zone, or so on. In my case I choose the flicker number 1, so it's section 3. And same thing for the experiment, the test 2, for the second experiment of the dataset. So I do this again, and the code computes the PSTHs. You can notice that it added automatically 2 types of PSTHs, the white flashes and the black flashes. That's because in the flicker stimulus I have 2 different types of repetitions, the white flashes and the black flashes. You can know something more about that if you check the tutorials about how to add new stimuli and how to write the repetitions of a new stimuli. So now that we are all good, we have a dataset, we have the PSTHs in the dataset, so you can check it out now. The PSTHs object has 4 different fields named after the 4 repeated patterns the PSTHs correspond to, and the responses are inside. So now I can visualize all the information about my cells using several functions. So first thing that we can use is this plot cell card, which plots all the information about one given cell. So for example, I choose cell number 1, and this is the plot that I get. So you can see this is all the information we have about cell 1. It comes from the experiment test, and it has we can see the interspike interval curve here bottom left, the temporal component of the spike trigger average, the receptive field, and also the PSTH to the Euler stimulus. So by default you will always show the first PSTH that has been added to the dataset. But if you want to show another PSTH, you can use this function here called change default pattern. So the default pattern is the default PSTH that is shown when you plot cell cards or other types of plots. Here I can put, for example, white, so this will show. Now the default pattern is the white flashes, and if I plot again the cell card 1, I will actually see a PSTH to the white flash. rather than plotting the whole card, you can also use this function, plot ISI, plot temporal STA, or plot PSTA, just to plot the components of the panel I showed you before independently. So for example, I can do plot ISI, and I will just have the ISI of the cell number 1 rather than the whole panel. So this is it for the dataset. So far we just created one dataset, but you can in theory create more than one. So let's say now I want to create a new dataset. So I'll use again the function set dataset, and this time I will call the dataset my second dataset, which will just be composed of experiment called test. So now I have two different datasets. I can list my datasets using this function, list datasets, and I can understand on which dataset I am in by using get dataset id. So now I am inside my second dataset. I can also change and go from the second to the first. Like this. So I'll get my first dataset. And you can do other things like delete a dataset, or copy. So when you copy, the first argument I think is the dataset you want to copy, and the second argument is the new name. So now if I list, I get all of them. So all of your datasets are saved in the dataset folder. So they will be there also when you close MATLAB and reopen it, and they are just saved forever.